Welcome to All This Math. This is Professor Parker, and today I got Frederick Douglass with me. I got my Frederick Douglass pen, and as Frederick Douglass said, it is better to build strong children than to fix broken men, or to have to fix broken men. So over here at All This Math, we're trying to do our part to contribute to what Frederick Douglass said by building strong children, and we're trying to build strong math skills in children so that later on in life, they're not broken men and broken women that don't have strong math skills, all right, so that they can't navigate this earth that we're on, all right? Also, if you have not yet subscribed to the YouTube channel, please go ahead and hit the button, subscribe to the YouTube channel. Also, turn on the notifications so you can be notified whenever new content is released. Now, let's take a look at what we're getting into today. Today, we are going to write x is greater than 3. That symbol right there, that's an inequality symbol, which means greater than. So we read it from the left to the right. The open part is facing the larger quantity, right? So that means x is greater than 3, all right? Remember that. Write x is greater than 3 in interval notation. Let me underline that because that's important. Interval notation. Interval notation, all right? That's something we're going to get into. And graph it. So we're going to write it, and we're going to graph it. Well, we're going to write it in interval notation, and we're going to graph it. All right. Now, what is interval notation? Interval notation is another way to represent this, right? This is called set builder notation or set notation, right? Interval notation involves brackets and parentheses. So keep that in mind. It involves brackets and parentheses. And within those brackets or parentheses, and sometimes there's a combination of brackets and parentheses, right? You will have the two extremes in which these values are represented. So let me try to break that down and make it more simple. So this says that x is greater than 3. So what that means that x can be any value bigger than 3, right? That's the solution to that inequality. Notice, this is not an equation. We're not saying that x is equal to 3. We're saying x is greater than 3. That means x could be 3.1, x could be 59, x could be 10 trillion, x could be 3.5, x could be 10, 58, 32, 29, any number bigger than 3. It can't be 3 because it's not also equal to 3. It's only greater than 3. It's not any number less than 3, so it can't be 2, it can't be 1, can't be 0, can't be nothing negative, all right? Any value greater than 3. So the way we represent that in what we call interval notation is we're going to show the interval. Now, with interval notation, this is what we do. We're either going to use a bracket or parentheses. Now, how do you know when to use a bracket or parentheses? If this value right here, this is called your boundary point. That's what we call it. We call that a boundary point, right? Because that's the boundary of the interval. If this right here is included as one of the x values, then we use a bracket. But this ain't included as one of the x values because we said that x is greater than 3. We didn't say x was 3. We said x is greater than 3. We didn't say x was equal to or greater than 3. We just straight said x is greater than 3, right? So check this out. Therefore, we're going to use a parenthesis. Boom, like that. Now, next to the parenthesis, we're going to put the 3, right? Because that's like the beginning of the interval. The interval starts at 3 because x is greater than 3. So that means x is like, so from 3 on and on and on forever to what we call infinity are all the values that satisfy this inequality, right? So the interval goes from 3 to infinity, from 3 to infinity, right? So we put a comma right here, and then we draw a symbol for infinity, which is basically a sideways 8. Now, the rule with infinity, you never have a bracket next to infinity, whether it's negative infinity or positive infinity. You're always going to have parentheses next to infinity, right? You're always going to have parentheses next to infinity. That's something for you to memorize when you're doing problems like this. You will always have a parentheses next to infinity, and you know if you put a parentheses or a bracket next to that number, if it's included in the solution set, right? Right here, this 3 is not included because, like I said, we didn't say x was equal to 3. We said x was greater than 3. Just like if in another example, x was less than 3, that don't mean x is included include, that don't mean that 3 will be included. It would still be less than. So therefore, use a parentheses. All right. So this is interval notation right here. Boom. So when you want to put something or take something from set notation and put it in the interval notation, this is how it should look. Now, second step is to graph this. So we're going to graph this. So when I graph it, I'm going to draw a little number line like this, right? Basically, it's the x-axis, right? That's all a number line is. A number line is just the x-axis from the xy coordinate plane, but we only need the x-axis though. And then I'm going to put some line markers, right? Now, you can go through the trouble of like numbering this, but you might be wondering like, well, where should I put the numbers and what number should I put? You definitely want to have your boundary point on the number line, right? So my boundary point is 3. So I might put a 3 like right here. And I like to also have 0. I like to also have 0 on my number line. So numbers get bigger as you go to the right, right? So 2, 1, this is 2, this is 1, this is 0. So we got 0, 1, 2, -1, 4, 5, and 6. Now, when you're graphing, you want to find your boundary point, which is 3, right? So what I do is I say, okay, I found 3 is right here. Now we got to make a decision, right? Now, are we going to draw a circle around 3 that's open, or are we going to draw a circle that's shaded in? Now, if 3 is included, right, or if there was a bracket, we would do a shaded in circle. But because 3 is not included, we draw an open circle. So I do that, right? Open circle, not shaded in. We shade it in if the boundary point is included. This is a rule for you, right? You probably want to write this down in your notes. If the boundary point is included, you shade in the circle. If the boundary point is not included, you don't shade in the circle. All right? Included, shaded. Not included, not shaded. Like right here. X is not, again, I keep going back to this. We didn't say X was equal to 3. We said X was greater than 3. So that means X is any value greater than 3. It could be this 4, it could be 5, it could be 6. It could be any of these decimals or fractions in between 3 and 4, in between 4 and 5, in between 5 and 6. It goes on and on and on. This arrowhead means this number line goes on and on and on forever. All right. Now, we got to draw a number line. Now, what I usually do is I do like this. I go up and over so it can be distinguished from the number line, but that's just me. Some textbooks will just be like, they'll just do like this. Superimposed over the actual number line. Either way is cool, So, we're done. We wrote X is greater than 3 in interval notation, and we also graphed it. That's all you got to do. So, if you need to, you can rewind, pause, go back and forth. All you really need to understand with interval notation is when do I use parentheses and when do I use brackets. In this particular example, we didn't use brackets, right? Also, infinity will always have a parenthesis next to it. And when you're graphing, you just find your boundary point. Sometimes you'll have multiple boundary points, but you find your boundary point and then you say, okay, well, where are those X values at? That's why you got to ask yourself, where are the X values at? Are the X values to the right of 3? If this says X is greater than 3, ask yourself, like, where are the numbers at that are greater than 3? Where they at? Are the numbers greater than 3 that way? They not. That's why I didn't draw my line that way. The numbers greater than 3 are this way. That's why you draw the line that way. See these numbers, 4, 5, 6, and all that? It's that way. That's why the line's going that way. You know what I mean? All right. So again, if you haven't subscribed to the channel, please go ahead and subscribe to the channel. Also, turn on the post notifications and share this video. Tell somebody about what we're doing at All This Math. And as I always say, remember, there's all this math all around you. Peace.